Well, we have that countdown there again. You see, this happens every single time. Wait, let me just see if I can fix that up again. Start again. So you can only have one thing at a time. I see. Okay. Well, anyways, guys, you know what? Let's just do it this way. It's a bit more easier. Cool. Hello, everyone, and welcome to the second session. We're going to be learning. We're still learning about algebra, and you want to be learning about the basics of algebra. So that's exactly what we're going to be doing. Now, if you were here last time for the sessions, you would have noticed that we made quite some progress as previously, and we basically covered how to simplify certain expressions, and we even covered how to expand certain expressions and how to work with it. But so far we will only be dealing with sort of linear equations and some maybe quadratic equations, but we'll get a bit deeper into that hopefully within the next two sessions, because we have a lot to cover. I'll tell you the topics that we're going to be covering by the end of this. By the end of the first four sessions, we're going to be covering basics of algebra. We're going to be covering some indices and surds and how we're going to factorize, and simplify all of those and everything. We're going to be covering basic functions and how to work with functions within the realms of x and y, presumably. The most simplest ones. We're also going to be dealing with quadratic equations, how to solve them without using any graphs or anything. We're also going to be dealing with equalities and inequalities. That's quite a broad subject. We're going to be dealing with algebraic division and fractions. And finally, we're going to be dealing with partial fractions. So that's a lot to cover within just four sessions. And as you can imagine, because there's a total of 6 different topics to be covered within the core mathematics series, it has to be really quick. So as you can imagine, last time we did so many questions within a short span of time. This time, and possibly moving on from here onwards, it's not going to be that quick. Instead, what's going to happen, I'm not going to try and solve the entire book. What I'm going to try and do is I'm just going to try and work out some nice questions. I'm going to try getting a medley of all different kinds of chapters, topics to work through. So anyways, last time the thing that we worked on was basic simplification, I believe, and sort of factorizing. So we worked on the last one, which was 15x squared, 42x minus 9 equals 3. So we worked on this equation, and so it basically allowed us to work out that if I was to factorize this entire equation, it would turn out to be this. And now that's a basic quadratic equation that you can see over there. But we're going to try and find out, and we're even going to work through other quadratic equations where it's not possible to simply visualize or sort of predict the common factors that could potentially, give you the factorized equation for the expression. So we're going to work through that, and we're even going to talk about possibly the quadratic equation and the likes of those. Okay, so moving on from there, we're going to still carry on with simplification and some evaluation, and hopefully from the next session onwards, it's going to get a bit more complicated. So we will try and take it as it goes. Essentially, we're not going to worry about plotting graphs or anything at the moment. When the time is right, we're gonna because that's a whole other topic. So when we're talking about coordinate geometry, we're going to talk about how to sketch curves and all different types of curves, including vectors and parametric equations, those kind of things. But anyways, for now, we're just moving on with simplification and evaluation. And I am due to get in a new pencil because I do believe I'm having some problems. But we'll see how this goes, and hopefully this time around it's not that difficult. Okay, back to simplification. This is session 2, so I'm just going to write session 2 right at the top. Oh, what's happening there? Okay, don't want pressure. So that's session 2, and yeah, we're just gonna delve into it. We'll start by titling it in black. Also possibly reducing the pen size. So we're gonna try and simplifying some more equations. That's a horrible M. Simplify. But it's not really equations, it's more like expressions. Okay, because at the moment we've not dealt with any kind of equation. An equation is where we're basically relating one part or one expression to a different expression. So for example, if we talk about this one, you see that's what I'm talking about. Okay, so if we talk about this one, x cubed divided by x to the minus 2, that's an expression. And we are going to try and simplifying this by using the rules of indices, and that would lead us to x3 minus 2. And for those of you that didn't get it, the minus 2 is already there. So if you have it divided by minus 2, you know, you can basically write it two different ways. So one, it could go that way, and that would give you x to the 5. And the second way is you could do x to the 3 divided by x to the minus 2. So that basically is the exact same thing written down here. And if I was to equal that, that would still give me, because the minus 2 would just sort of bring this entire term upwards, and you would get x to the 3 multiplied by x to the 2. And that would give you x to the 5. Same answers, different ways, but yeah, you can, whichever one sort of works better in your head, you can pick that one and lunge for it. Just gonna lock that over there so that we don't have any issues. Cool. Number 2. Let's try picking out a different equation. We're not gonna go sequentially now, as previously stated. If the time comes and if we have time to recap in the possibly last session, we're gonna try doing a bulk of different questions. But for now, we're just gonna try and rush through all the different topics, because there are quite a few topics within this specific topic itself. There's quite many subtopics. Okay, so let's do a more complicated one. We have x 3.5, so x to the 3.5 multiplied by x to the 5. Well, it's not 3.5, it's 3 over 2. So it's actually 1.5. And that one is actually 2.5. Okay, cool. So again, two different ways to solve this. Or possibly not. You can actually just solve it one way. We're going to use the basic rules of sort of adding fractions over here, which basically brings us to this. So we have x to the 3 divided by 2 added 5 divided by 2, okay, which would give us x to the 8 divided by 2, which ultimately gives us x to the 4. And that's the final answer. Let's try a bit more complicated one. Let's pick out... right, single circle that. Right, so let's pick out x to the 3, and that's whole to the 5 divided by 3. Now, just by looking at this, you can easily say that it would most likely be x to the 5. And if you want to show you're working out, it will basically be like this. So we have x to the 3 multiplied by 5 divided by 3. So 3 and 3 cancel out. You know, you basically just figure that one out, and you end up with x to the 5. Simple. Let's try another one. Something that looks a bit more complicated. Alright, let's do this one. So we have 5x divided by... sorry, no, it's 5x to the, of course. There's going to be some indices in there. So we have 5x 1 and 2/5 divided by x and 2/5. So basically you can see what's going to go on over here. You have the 2/5, so it's basically 1 and 2/5 minus 2/5, and of course you basically just divide 5 by 1. Now the way that you can sort of work with this is you sort of you basically sort of disregard the different terms, because as you can look, it's basically multiplied. So if I have 5x divided by x, I can basically cancel that out, because that's a common factor between both of these terms. So between 5x and x, you have x, which is a common factor, so which is why you can cancel it out. Similarly over here, if you find yourself having a constant in front of a variable, and then you're dividing it by the same variable, you can basically deal with the variables separately and the constants separately. So if this was by any chance 5 divided by 15, you would basically deal with x separately, and then you would deal with 15 and 5 separately, and whatever you would get, you would use as a compound answer. But anyways, for this specific question, you know, I'm running off into the explanation mode again. I'm simply just here to solve equations, so you know, I'm just going to stick to solving equations. You guys possibly know definitely the answer to these basic equations. So yeah, it will just be 5x essentially, because you have 5x, and then you have 1 2/5 minus 2/5, and that would give you 5x to the 1, which can be just written as 5x. Alright, we're going to do one more of simplification, and then we're going to move on. Let's see what's a bit more complicated. Yeah, I found the one that I was talking about. So yeah, we'll do 9x 2 divided by 3 to the 2/3 divided by 3x and 1/6. Okay, now if I was to write this out, of course, I would know that it would just basically help me think better if I wrote it as 9x to the 2/3 divided by 3x to the 1/6. Okay. Right. So I can basically deal with 3 and 9 separately, so that gives me 3. And yeah, and for me to deal with the x bit, I need to make sure that they both have you know, a common denominator, so I can basically either add or subtract them. In this case, I'd have to subtract them. So I'm gonna be ending up with 3, and let's see if I can do this in my head. So I'll basically have to multiply this whole thing by 2 to get no, that's not how it worked. Right, so it'd be 3x, let's just write out 2 divided by 3, 3 and 6, so you have 6 being a common multiple, lowest common multiple, and I'd have to multiply that by 2 to get 4, and of course that's just 1, so you get minus 1, and that would end up with 3x, 3 divided by 6, which would give you a half, 1 divided by 2, cool, which can also be written as 3 square root of x. I'm just going to double check this one, because I'm afraid my lowest common multiple theories are not specifically perfected at the minute, because I'm still catching up. So yeah, we'll just write this out. So we have 9x to the 2 divided by 3, and then you divide that by 3x to the 1 divided by 6. Okay, so we have that, and we're going to try and find the answer. Hopefully it will give us a reasonable answer. Right, so simplification of this has definitely not tended in the right direction. I'm not entirely sure why. Let's just run through this. Right, to multiply the powers of the same base, add their exponents, add 2 to the 3 and 1 to the 6. To get their exponents. Why are they adding it? Oh my god. Honestly, there's something wrong with these... why is there something wrong with this? It's just so weird. Yeah, no, there's definitely something wrong with this. I don't know. This, I'm gonna have to... Yeah, I'm gonna have to raise that as an issue. That's definitely weird. We're not gonna be using this anymore. Because, yeah, it's just messed up. But no, yeah, I basically did it right because they've been adding it for some reason. I don't know why, because that when you bring that up and you sort of multiply it, that has to be a minus, not a plus. So yeah, there's definitely something wrong with the theorems going on over there. Not entirely sure how. Okay, so that's the last of the simplification. We're going to move on, and we're going to start with evaluating some expressions. Now, in terms of evaluation, it doesn't necessarily mean that there's going to be variables or anything. We're just going to have to deal with just the equations as it comes along. So we're just dealing with sort of indices and surds, essentially. So evaluate, right, you can write this in a black color for easier reference. Evaluate. And yeah, let's go. So we have the first question, which is 25, 1 divided by 2, which can also be written as square root of 25. So you have a square root of 25, because that would basically be, 2 to the minus 1, essentially. Yeah. So you have that, and that is equal to 5, I believe. Yeah, because 5 times 5 gives you 25. Second question, what are we going to pick? Let's do minus 5, and we're going to do to the minus 3. Okay. Right, so in this case, it would just basically be the cube root of minus 5. I suppose that's an easy way to write that down, 100%. And of course, when you're doing cube roots, you also need to bear in mind that actually, not only when you're doing cube roots, even when you're doing square roots, you must bear in mind that that's actually not true. Right now. So this would basically be well, it would be a negative number. So you could just basically cube root minus 5, and you know that would be a negative number. So you can either leave it as that, or yeah, you can possibly just leave it as that. Okay. I feel like I took a way too long pause over there. Anyways, let's move on. Number 3. Let's do let's do 9 to the minus a half. How's this gonna work out? Okay, so 9 to the minus a half can be written as 1 over 9 squared. No, that's wrong. Sorry. 1 over 9, and then to the half. 9 to the half. 9 to the half. However you want to call it. Right, and that equals, you want to do like a square root of 9, so 1 divided by square root of 9, which would be equal to 1 divided by 3. Because the square root of 9 is 3, because 3 times 3 is 9. Cool, and that's the answer. That's also the answer for the second one, and that's also the answer for the first one. Right, yeah, before I forget, because when you're doing square roots, you basically end up with like a plus or minus, and the reason for that is if you multiply a minus term or a plus term, you could basically end up with the value. For example, if I was to do minus 3 multiplied by minus 3, I would still end up with 9. Whereas if I was to do 3 multiplied by 3, I can also end up with 9. So therefore, the square root of 9 would also give me either plus or minus 3. Do you get me? Because it's not definite. It could basically end up with either of these scenarios. So essentially you're not entirely sure which scenario it would be unless you have a negative right outside. So unless you're multiplying it by minus, in which case it would be the opposite of whatever this is. That's what you would get. Yeah, but that's not what we're going to be sort of worrying about right now. But yeah, that's basically exactly why you end up with a minus or plus. Again, I feel like I'm explaining too much. You guys probably know this already. Probably going to worry about it at some point else. You guys should watch the lecture series. I don't think I've mentioned it enough, but definitely the lecture series is something that people could easily benefit from. So I would highly recommend giving that a go. We're going to do a slightly more complicated one this time. We're going to do 9 divided by 16. So 1 whole, 9 over 16th, so 9/16. And the whole of that is to the 3 over 2, so 1.5. What we're going to do is first we're going to simplify this big chunk over there. And we're going to end up with 16 plus 9 is 25, so we have 25 divided by 16, and then the whole 1.5, or 3 over 2. So if we rewrite this, we end up with 25 3 over 2 divided by 16, 3 over 2. Now, as you can imagine, 25 and 16 are both sort of square numbers, or they're numbers that they're basically whole numbers that are formed. They're basically simple numbers that are formed when you square numbers. So if I was to square root that, because yeah, let's just write that down. It would basically be what's his face? Yeah, it would basically be 20 square root of 25, and then cubed, and the same at the bottom. So you would have square root of 16, and then cubed. So you'd end up with 5 cubed divided by 16. 4 cubed. And that would be 125 divided by, well, 16 times 4, you get 24, and 24 plus 5, 64, I believe, 64. Yeah, for those of you guys working with computers and stuff, you know that 64 is the number that, you know, that people work in terms of having memory. Yeah, random access memory. It comes in multiples of 8 or multiples of 4. Previously it used to come in multiples of 2. Technically still does. Not multiples, sorry. It's sort of squares of 2. Because you have 2, 4, 16. No, actually, you do get in multiples here. You do 2, 4, 8, 16, 32. Yeah, you can also get 32. It's also true. Not just 64. But yeah, so that's the cube, I believe. Cool. Moving on. Right, so that's the answer for that one. 4, 5. Let's do one last one, and I'm going to call evaluation for that a day. I'm sorry, people, I'm not having a very... I believe you can possibly feel the nasal tone in my voice. It's just I've been a bit under the weather. Nothing serious. Hopefully it will just fade. But yeah. So that's going to be 3 to the 0, which is always 1, and 4 to the 0, which is always 1. Which is equal to 1. Yeah, just going to write 1. And that's the answer. Cool. Alright. Let's try and move on and see if there's anything new within the realms of basic algebra. Right. Yeah, let's do some more simplifying rather than evaluating. So yeah, we're just going to go back to simplifying again. Simplifying. Simplifying. So let's do square root of 28. Now if I was to divide 28 by 2, I'm going to get, what would I get? (28) divided by 2 would be 14, right? Yeah, it would be 14. So if I do 28 divided by 2, I get 14. And if I divide that further by 2, I'm going to get 7. So that can also be written right now. I'm not writing down the numbers. What's wrong with me? Right, so let's just write 1. And we're going to be dealing with square root of 28. I'm trying to find the simplest value to how to easily simplify this. So this can also be written as the square root of 2 multiplied by 2 multiplied by 7. 7 times 2 is 14. 14 times 2 is 28. So as you can see, we have two sort of common multiples over here. So we have 2 times 2, it's just square, which can then be written as square root of 7 multiplied by 2 squared. And the square root of 2 and 2 cancel out. So you would end up with, let me see if yeah. You know what, you just end up with square root of 7 and 2 over there. Cool. Let's move on to the next page. Number 2. Good question. Let's do a tough one over here. We're going to do square root of 44 divided by the square root of 11. Now I'm sure you can appreciate 11 is a prime number, so we're not going to be able to find a square root for that. But what we can do is we can separate the terms over here. So this would equal to the square root of 4 multiplied by the square root of 11. Because 11 times 4 gives you 44. And if you multiply them, then yeah, you basically end up with square root of 4 and square root of 11. So yeah, essentially. And this is divided by the square root of 11. So we can technically, essentially, basically cancel those two out. And you end up with the square root of 4, which is 2. So that is the final answer. Seemed complicated, is not. You just have to sort of think it through and try to figure out what's the easiest way to approach it. Let's do a compound term now. Of course, we did a compound one before this as well, as an expression, sorry. We're going to do a compound expression now as well. So we have square root of 20 plus square root of 80. Now, that's an interesting one. Let's try to see how we can tackle this. So you divide 8 by 2, you're going to get 4. You divide 8 by 2 again, you're going to get 4. Am I correct? No, you're going to get 2. Sorry, you're going to get 20. So if I divide 80 by 2 by 4, I would end up with 20. Yeah, does everyone agree? Okay. So yeah, I can also write this as square root of 20 plus square root of 4 times 20. Yeah, you guys agree? Okay, so we end up with, you have a square root of 20 plus 2, because you know the square root of 4 is equal to 2, so that basically it's a basically multiplicative term now. So it's basically 2 multiplied by the square root of 20, sorry, square root of 20. And now what do we know about sort of adding these terms? Let's pretend 20 is a variable. So the square root of 20 is a variable. Yeah, we can just basically add 2 plus 1, and we would end up with sort of 3 square root of 20. And if you wanted to write that as a compound square root, you could basically also write that as, as 180. Sorry, is it 180? 9 times 20, yeah, 180 square root. Because it would be, which is also equal to square root of 9 multiplied by 20. So that and that is exactly the same. Just depends on how you write it. Again, if you ever need to sort of work out something and you want to find out the right answer, you can literally sort of play around with these equations, get the right answer. As long as they both exactly mean the same, as long as expressions mean exactly the same, they're usually interchangeable. So yeah, you can write one as the other. It doesn't really matter. But in terms of sort of simplifying, getting the simplest term in this reference or in this situation, I possibly say that going with 3 square root of 20 is possibly the easiest way. Let's do another one, and this time we're going to do a little bit more lengthy equation. So we're starting to get used to some bigger equations. 175 plus the square root of 63, which I do believe has something to do with 9 or maybe 3, I don't know, plus 2 the square root of 28. You know, you remember we did with square root of 28, and that we're going to work through that again, but I believe it was something to do with like 4 and 7 or something. So yeah, we'll figure that one out. And again, 63, you have 9 multiplied by 7, which gives you 63. 9 multiplied by 7 gives you 63. 9 multiplied by 1 gives you 9. 9 multiplied by 2 gives you 18. 27. 36. Yeah, sounds about right. 36, 45, 54, 63. Yeah, so you have that one as being sort of 7 multiplied by 9. And you have this one, I'm presuming it has something to do with 7, but I don't know what it would be. But if I had to guess, I'd probably say it's 25 multiplied by 7. So just by having a look at this, I can say, okay, 175 is a multiple of 25, and 25 is a square root number. It's a square number. So as in you multiply 5 together by itself, and you get 25. So essentially, this whole equation can be written as the square root of 25 multiplied by the square root of 7 plus the square root of 9 multiplied by the square root of 7 plus the square root of... Right, so it'd be probably the square root of 16. But instead, I'm just gonna write it normally. So you have 2 multiplied by the square root of 4 multiplied by the square root of 7. 7 times 4 is 28. 7 times 3 is 21. 7 times 2 is 14, and 7 times 1 is 7. Yeah, that's right. Cool. Okay, so yeah, as you can see, 7 is the common factor all over. And if I want, I can basically just write it in one straight equation. And it would look like this. If I take out the square root of 7 as a common factor, it would look like that. So you have square root of 7 multiplied by the square root of 25 plus the square root of 9 plus 2 and square root of 4. So again, however you write it, as long as you write it correctly, and of course, the addition, you're taking out common factors over there, like, you know, you're taking out common factors between the plus signs or the minus signs, not in between multiplication and division, essentially, because that's not acceptable. But yeah, we just do that, and yeah, we end up with square root of 7 multiplied by 5 plus 3, sorry, plus 4, because it's 2 times 2. Square root of 4 is 2. So you end up with, which is essentially 12, I believe, and that equals 5 plus 3 is 8, 8 plus 4 is 12. 12 square root of 7, and that's the final answer for that one. So big equation, simple working out using the basic rules. You got to keep track, because look, when it comes to big equations, you have so many different terms. You have to keep track of all the operators, and the operators are the addition signs or the minus signs, and the multiplication and the division signs, and even brackets, actually, because brackets play an important role. Depends on where you put the brackets, so you need to be careful about that. But yeah, okay. So you know what? That's a really good point. Let me try doing the. Let me try doing that one, and if I write that in, and try putting that into brackets. So we have all of that into brackets. I wonder what comes up next. Okay, so you have that. Let's try solving that. Then I should end up with 3 over 2, which is that right? I don't think that's right. X 2/3 minus 1/6. Yes, that's absolutely correct. Yes, 2/3 minus 1/6. But that still wouldn't give you 3 to the 1, 3 to the, what, 3 to the half? How do they give you 3 to the half? Because then you'd be, that'll be multiplied by 2 to give you that. And you have basically 4 multiplied. No, it was a half. It was a half. Alright, so yeah, no, definitely. That's the thing. I think, yeah, you need to worry about the brackets when you're using that. Damn, that's pretty insane. I think it was this one that we said that it was like 3 to the x, and yeah, I think if you use brackets, you end up with 3 square root of x. So yeah, like I said, I mean, having sort of brackets is very, very important, because that changes the entire the entire answer to the solution. So as you can see, it's happened twice now. I've not used brackets specifically, and they've just assumed that there's no brackets. So it's like a sequential solving when it comes to things doing on the computer. But yeah, if you use brackets, it does work out that way. So yeah, keeping track of operators is very important, and you need to make sure that you have a grasp of which operation you're allowed to do with which operator present. So for example, if I was to take out the square root of 7 as a common factor, I need to know that I can only take it out a common factor within the terms or the expressions that are separated by the addition sign. Whereas it would be different if everything was just multiplied. Yeah, it would be very different if everything was just multiplied. Cool. So let's carry on. Let's move on. I think, is that the 5th question? There's a 4th question. Well, let's do one more, and yeah, we'll just move on. Let's do another slightly bigger one. Again, hopefully by now it's not making so much difference, and it's just basic sort of math for everyone that's sort of practicing as well. So we have 18, it's 9 times 2 is 18. 200, you have 20 times 10, or basically 2 times 100, which is basically 10, sure. And then you add that with 72. Oh, sorry, no, that's not add. So minus root 72. 72, and if we divide that by 2, we end up with 31. No, it wouldn't be 31. With 36. Divide that by 2, you end up with 36. Yes, that's correct. Yes. So let's do that again. So yeah. So we have square root of 100 multiplied by square root of 2 plus square root of 9 multiplied by the square root of 2 minus square root of 36 multiplied by the square root of 2. 2 times 36 is 72. 2 times 9 is 18. 2 times 100 is 200. Okay, everything checks out. Now let's just go through with it. So we have 10 square root of 2 added 3 square root of 2, take away 6 square root of 2. So I'm possibly thinking I'm going to end up with 7 the square root of 2. So it'll be 7 to the square root of 2. And yeah, that would be basically because you have 3 plus, 6 minus 10 is 4 plus 3, 7. Cool, and that's the answer. We're going to try moving on. We're going to do some rationalization. If you guys want to take a break, I think I'm definitely going to take a break. I'm not exactly feeling all very well because of my nose. But yeah, we were going to take a break, and when we come back, we're going to start rationalizing some surds. So we'll just rationalize some surds. Okay, or some expressions. All right. We're back in 10. Actually, make that 5. So we're back at 6:45. Okay, hello everyone. We're back. Yeah, no, it was basically specifically sort of 6:45 based on the time that's running on this machine that I'm working on. So yeah, we're just gonna get back to business, right? So we're gonna start rationalizing some equations, and we're gonna try moving a bit quickly through this because we have to cover quite many different topics, as many of you guys can appreciate. But yeah, I'm not entirely sure. To be entirely honest, for me, it's just about getting through all of these equations in bulk. So we're trying to get through as many equations as possible. So I'm not sure entirely that the idea of just half completing equations is a good idea. But yeah, we'll just try to work through it because I've already started the session now. It's been 46 minutes. I don't want to restart. Alternatively, I might actually do another session where I'm just gonna, instead of working through. No, you know what? This is a good idea. Whatever. Let's just work through it. Cool. Sorry, I feel like I'm speaking too much. Okay, cool. Let's try rationalizing the first term. We have 1 divided by square root of 5. Yeah, all of these thoughts that I'm thinking is kind of something that I should be thinking in the background. But I feel like I talk to you guys as well. So, yeah, if you leave me any comments later on as well, it's always good to have an idea whether I'm doing something right or I'm doing something wrong. Okay, now the purpose of rationalizing a surd is to ensure that the denominator of any fraction is turned into a whole number, something that you can deal with. So the way that you do that, if I was to simplify this expression, I'd basically multiply the top and bottom by the square root of 5. And I would end up with, the reason I'm saying implies, actually no, if I just say equals, because you're multiplying it top and bottom both. So yeah, it would technically, yeah, you can do that in a proper equation as well, not just an expression. So you have square root of 5 at the top because you multiplied it by 1. And you have the square root of 5 at the bottom, and you multiply that by the square root of 5. Now, both of these, of course, you can imagine what happens. You basically end up with 5 times 5 is just 25, and the square root of 25 is 5. And at the top, you end up with the square root of 5. So that ends up with square root of 5 divided by 5. Not 25, it's 5. Right, that's your answer. It's the way that you rationalize this specific term. Yeah, sure you guys got that. Cool. Number 2, let's try doing a different one, a bit more complicated. We're doing the square root of 7 divided by the square root of 63. Again, similar thing going on over here. We're trying to get sort of similar terms. But now first we're going to try and see if we can actually cancel out the square root of 7. And if you don't want to do that, you can possibly try doing that at some point later on. You'll see what I'm saying in a bit. Cool. So if we multiply the top and bottom by the square root of 63, we end up with square root of 7 multiplied by the square root of 63 divided by the square root of, no, not the square root, sorry, my apologies, it would just be 63. Square root of 63 multiplied by square root of 63. Okay, yeah, and that equals square root of 7 multiplied by the square root of 7 multiplied by the square root of 9, because 9 times 7 gives you square root of 63. So you have square root of 9 multiplied by square root of 7 gives you 63, and you have square root of 7, which is the first term that we had, and you get that divided by 63. Because multiplied by that, yeah. And if we sort of carry on the equation, we end up with 7 multiplied by 3 divided by 63. So you basically end up with 1/3. Basically, yeah. Because 7 divided by 63 is 9, 3 divided by 9 is 3. So 1/3. That's the final rationalization for that. So as you can see, when you try and rationalize something, it does end up a little bit more simplistic, as it is. Once again, I feel like something has been done wrong. I don't know. Maybe. I don't know. That's a little bit weird. Let's try doing this a different way, because I am having my doubts. Okay, so if I was doing it the different way, so if I have square root of 7, and if I have square root of 7 multiplied by the square root of 9, it should give us 63. So if I cancel that out, you end up with 1 over square root of 9, which then equals 1 over 3. So in that case, you don't actually have to rationalize to get anything. So yeah, that does give you the same answer. Okay, that has been cleared. Usually, if you have any doubts, I'd probably recommend doing this kind of secondary calculations in like a rough workspace where you basically just write down rough. You basically just write down rough and you're like, oh, yeah, right. Oh, right. So, yeah, got that right. Boom. But yeah, that's probably something that I used to do in my exams as well, and it really did help me. So yeah, it's always good to double check as well, because I don't have to remind you guys, working in sort of very serious trades such as engineering, architecture, and even medicine, to be entirely honest, you need to have calculations that are on point. And you might be surprised, even if you're doing medicine, you need to be very, very sharp when you're talking about, general core mathematics calculations. And they deal with a lot of basic concepts that we go through over here. So yeah, keep that in mind. All right, we're going to do another one, and this one's going to involve keeping a much slightly more complicated term. So we have 2 plus square root of 5. Cool. So if we multiply this by 2 minus square root of 5 and 2 minus square root of 5. Now bear in mind, you could also do this you could do the exact same thing, only if it's an addition. You could do like square root of 5 minus 2. Yeah, so you could do that as well. And the reason for that is it would basically give you the exact same answer, because this can be written as square root of 5 plus 2. So if you find yourself, that's a little bit complicated, like, why do I have a negative square root? Like, first of all, don't worry about it. Second of all, if that does happen, you can basically reverse the orders. But in this case, I'm not going to reverse the orders, because I want to find out what it actually turns out like. So we're going to do 2 minus square root of 5, square root of 5, and 2 minus square root of 5. And we end up with 2 minus square root of 5 divided by, and now we have 4 minus 5. Does anybody agree with that? I don't agree with that. Yeah, no, let's do this a different way. So 2 minus square root of 5, and then let's do 2 multiplied by 2 gives you 4. Right, so that's the first term. The second term, right? The second term is 2 multiplied by square root of 5, so is minus 2 times square root of 5, and then we have plus 2 times square root of 5, right? So that does cancel out, doesn't it? Yep, it does cancel out. Okay, cool. Right, so that ends up with 4 minus, right? This is basic difference of squares, isn't it? Because yeah, you multiply both of those and you get the difference of squares. So you get 4 minus 5. Yeah, because it'd be okay, essentially, and then you would end up with that equals to what? So you end up with minus the whole of 2 minus root to the 5 divided by 1, of course. And that would essentially give you square root of 5 minus 2. Now, if you do remember, I actually did tell you that it would be much easier to do that to begin with, but that's not always going to be the case. This is only the case right now because, you have the square of the square root when it comes out is greater than the square of the initial term. For example, if this was 3, this would not be the case. You still end up with negative 5 at the top. It's much easier when you're doing examples, hence I'm just going to carry on. It's a bit all over the place. Sorry for that today. We're just going to sort of work through the different questions. I know this is like a demo of what happens when somebody's ill and you still have to work through whatever you're working through. You just have to get it on. There's no sort of escaping it. You have to get it on. Okay, let's do a different one. We're going to do 1 divided by 3 minus square root of 7. I'm going to presume we're going to end up with a similar problem, but we're going to work through it anyways. And we multiply that by 3 plus square root of 7. And the reason for that is, of course, is because you found out when you multiply an added sort of expression to the negative of the same terms, and one of the terms is negative, you end up with the difference of squares, which is quite powerful in terms of rationalizing surds. I know you guys have been taught this, but understanding this on a basic level makes it a bit more easy to work with. Okay, so we end up with 3 plus square root of 7 divided by, okay, and you have the square of 3, which is 9, minus 7, minus b squared, a squared, x squared minus b squared, yeah, a squared minus y squared. Cool. So you get 9 minus 7 gives you 2, so you end up with, I didn't do that, okay, you end up with 9, sorry, you end up with 3 plus square root of 7 divided by 2. Cool. Let's move on, let's do another one. A little bit more complicated one now this time. We are going to do square root of 41 plus square root of 29. And we're going to do square root of 41 minus square root of 29. Okay, now what we're going to do is going to multiply it by square root of 41 plus square root of 29. And we're going to divide that by square root of 41 plus, exactly multiplied, plus square root of 29. So remember the aim is to get, there's not enough space, right? Yeah, we'll just move on to the next page. You know what, I don't want to do this on this page. Alright, let's just go to the next page. Wait, how do I paste it? Way. That's pretty cool. Then I can do that. Okay, so you have that, and yeah, let's start working with it. So you have 41 minus 29 at the bottom. 41 minus 29 gives you, so is that 30 minus 42 gives you 12, I believe. Right, so that'll give you 12 at the bottom. At the top, you would end up with 41 and 41 plus 2 square root of 41 multiplied by square root of 29 plus 29. Wow. It's not complicated at all. Alright. Alright, let's move on. That gives you 41 plus 29 is a total of 70. So you get 70 plus 2 square root of 41 is 7? Or don't tell me it's like an even number, is it? No. 3 and 11, so 3 multiplied by 11. No, that's wrong. 7 multiplied by 3, no. 7, no, it's not 7. Can't be 7. 9, definitely not 9. 11, 13, nope. What 29? Square roots, I'm looking for square roots. Square roots. Square root of 41 is 34. Nope. 30. Nope. 15. Nope, that's definitely wrong. 6 times 6 is 36. Nope. 7 times 7 is 49. But if you divide 41, surely you should be getting some kind of number. Is 41 not a prime number? 41 is not a prime number, is it? Is 41 a prime number? Oh my god, I think 41 is a prime number. So you get 3 and 11, that's not going to work. 4, nope. 5, nope. 3 didn't work, that's a shocker. 7 definitely doesn't work. Yeah, because you get 7 times 6 is 42. Nope. 8 definitely doesn't work. 9, not working. 10, nope. 11, nope. 12, nope. The only other one that I can possibly think of will work is maybe 19. 17. 17 times 3. No, because 17 times 2 will give you 34. Plus 17, definitely not 41. I'll give you like 51. 34 plus 17, yeah. 51. Okay, so 41 is a prime number. Wow. 29, also a prime number. 3, no. 2, no. 4, no. 5, no. 6, no. 7, definitely no. 8, no. 9, no. 10, no. 11, definitely no. 12, yeah, now 12 is 24, and 13 would be 13 times 2 is 26, 14 is 28, 15 is 30. Great! So they're all prime numbers. Wow, okay. Did not see that coming. Right, so 2, and you have square root of 41 multiplied by square root of 29. Prime numbers are just easy to leave like that, because nobody's got time to mess with prime numbers, dude. Because they're prime. Alright. Number 12. Yeah, we're going to take out a 2 as a common factor, and that ends up with... Let's see what that ends up with. So if we take out 2 as a prime factor, sort of a common factor, we end up with 2 on the outside, and you end up with 35 plus square root of 41 multiplied, so square root of 41 multiplied by 29, divided by, let's just get rid of that, divided by 12, 6, sorry, no, it'd be 12, actually, you know, the bracket was right, don't know what did I do that, 4, 12, and that gives you, I really need to start rearranging my equations a little bit more precariously, because, yeah, taking up a lot of space. Okay, so that equals 35 plus square root of 41 multiplied by, 41 multiplied by 29 and divided by 6. I personally believe that you cannot get any better than that, but I think it's better that we find out did I actually do that right or not. I don't know what's going on. Cool. Just gonna clear all. I don't think this is gonna be able to rationalize though. I don't know, let's have a look. Square root of 41 plus square root of 29 divided by square root of 41 minus square root of 29. Yeah, it's going to give you an answer. Yeah, it's fun, isn't it? Okay, evaluate. No, don't want that. Similar problems. No, don't want that. No, related concepts. No. How to simplify? Is it over there? Or to simplify a third? Yep. Doesn't have that specific one though. Let's see more items. No, doesn't have that. Doesn't have that. No, cool. Right. Yep. Does not have that. Definitely. But we know the answer, so it's supposed to get something like 11.58 something. Let's see if we get the same answer if we put in that. Or actually, yeah, let's do that. So you get 35 plus square root of 41 multiplied by 29. Yes, we do get the same answers. Cool. So that's another way to check it, of course. I mean, you're not going to have that sort of thing in the exam or anywhere that you double check. Is that 11 point something? Yeah, it's definitely right. Cool. So, yeah, you did it right. That's the answer. Man, I'm doubting myself a little bit too much right now. It's probably because I'm ill. Not too much. It's nothing serious. And also, it cannot be spread through the YouTube video. So none of you guys have to worry about anything. Okay, right, so we're going to move on, and we're going to try and do some quadratic functions. We're going to try and do some quadratic functions. Yes, cool. We're not going to draw any graphs or anything. We're just going to try and find out how to solve specific quadratic equations, and yeah, what's the easiest way to sort of various different methods of how to solve quadratic equations. So we're just going to do quadratics. You know what? Actually, I'm not going to jump to quadratics. What I am going to do is I'm going to jump onto we're going to do basic functions rather than quadratic equations. Basic functions. Right. Sometimes linear equations, elimination, qualities, inequalities, equations and inequalities. Let's go on 27. Let's see how this works. Okay, let's do some basic functions and understanding how to simplify them. We're going to do equalities and inequalities, but apparently we're supposed to do quadratic functions before that. Okay, right. You know what? Let's just move on with quadratics for now. Man, this is all over the place. I should be a little more prepared. Alright, we're going to do quadratics. We're going to do quadratics. Non-graphical. Boom. Okay, cool. So what we're going to do is we're going to say, yeah, let's try and solve the following equations. Okay, solving equations. It should be in a different color, isn't it? Oh, messed up. What color did I put that one in? This color's done in yellow. Why don't I put that in yellow? It's weird. Fit width. So lock it in. Quadratics, non-graphical. Yeah, let's just get on with it. We're going to solve some equations. I'm just going to write that in black as well. Cool. Simplify. No, sorry. Solve equations. I'm not worried about color. I'm just, yeah, I'm actually slightly worried about color as well. Got to keep it consistent. All right. First one, let's do basic. X squared is equal to 4x. Now we're going to solve this, so we're going to rearrange. And the way that you do it is you sort of, yeah, you look at the equality, sort of the operator that has been placed within there, the equating operator. So we say x squared, which implies x squared is equal, x squared minus 4x is equal to 0. We're trying to solve for x. So if we do x minus 4 is equal to 0, so x can either be 4 to give me 0, or it can be 0 to give me 0, because 0 multiplied by 0 is 0. So which implies x can either be 4 or 0. Yeah. Okay, that's the answer. X can either be 4 or 0. You know, to date I've never actually comprehended how this works. Yeah. But yeah, I'll probably comprehend this at some point later on in coordinate geometry. It makes sense once you actually visualize all of this. And for me, as a person who's going through the lectures and actually trying to create a workshop which allows people to simply learn, the core synopsis of mathematics, it is a bit difficult for me to sort of try and structure all the different ideas into an easy to learn format. But I'm going to try my best, and we're going to see how it goes. Anyways, hopefully this made sense. So basically, we're trying to equate it to 0, so x can either be 4 or it can either be 0 to equate the thing. Number 2, cool. Yeah. Let's jump onto a little bit more complicated one. You can say x squared plus 3x plus 2 is equal to 0. So we need to find something that multiplies to give us 2 and adds to give us 3. Same thing when you're sort of trying to factorize. So we're basically trying to factorize this equation, or evaluate the equation, whatever you want to call it. And we say which would imply, you know, I'm just going to do it on a new line. I love doing things on a new line. So it says implies x squared plus 2x plus 1x, or just x indeed, plus 2 is equal to 0. Simplify that further, which implies x plus 2 and, sorry, that's the wrong bracket, plus 1 x plus 2, because 1's a common factor, gives you 0. So then you end up with x plus 1 with x plus 2 as the common factor, which implies equals to 0, which then also implies that x can either be equal to minus 1 or minus 2. Now, the reason for that is that if x is minus 2, then you get minus 2 plus 2 gives you 0, and then 0 multiplied by anything else gives you 0. If it was minus 1, so you can basically get two different solutions to this. Two different ways you can go. A crossroad, you get a path, you get a choice. You can pick. Your life is a quadratic, maybe even a cubic. If you become lucky, you get 3 different chances. Pick whichever way you want to go. Okay, let's do the next question. I'm gonna pick out a random one. Ooh, the lucky draw. Let's do. Which one am I doing? Okay, let's do this. So we get x minus 7 whole squared is equal to 36. Okay, now what do you guys expect? Go on, don't be shy. We need to make this equal to 36. I keep forgetting that this is not a two-way stream, it's just a one-way stream. But anyways, yeah, I'm just going to carry on with it. So, yeah, which would imply x minus 7 whole squared minus 36 is equal to 0. Now, I don't know about you guys, but I'm pretty sure if x was 7 at both instances, then it would be equal to 0. No, but that's not what we're trying to find out. We need to also account for the 36. Of course we do. Okay, let's do that. So, which implies x squared minus 7x minus 14x minus 7x. 7 and 7, something doesn't add up, isn't it? Minus 7 adds to give you 14, multiplies to give you 49. Yeah, no, that's right. Minus 49 minus 36 gives you 0. Minus 49 minus 36 gives you 4 plus 3, 7, 9 plus 6, 15, so 85, I believe, yeah. So which implies x squared minus 14x minus 85 gives you 0. Let me just double check that. Addition is a little bit foggy. So you basically get 50 minus, so 50 plus 35. Oh yeah, that's right, 85 minus 85. Okay. Right, so we need to get something that adds to give you minus 14, multiplies to give you minus 85. That multiplies to give you minus 85. Oh my god, there's something wrong again. Cool. That's supposed to be a positive 49. So you get minus 7 squared. So you get minus 7 multiplied by minus 7. Yeah, that'll give you 49. Like a positive, not a negative. Which would then imply that this is not 85. This is in fact, so it'd be 49 minus 36. So that'll give you 13. If I'm not wrong, 13. Plus 13 actually. Something that multiplies to give you plus 13 and adds to give you minus 14. Isn't that convenient? So that implies x squared minus 13x minus x plus 13 gives you 0. And which would then imply x as a common factor. And then you have x minus 13. And if you take a minus 1 as the common factor, you end up with x minus 13. So you've taken out the minus 1, sort of sucked out the negative energy from the positive. It's basically made it negative because there is no positive. You have to have two negatives to create a positive. So then equals 0. And which then again implies sort of x minus 1 with common factor x minus 13 is equal to 0. Okay, and which then finally implies that x could equal to either 1 or 13. And that is that. It was literally the end of the page. Wow. So as you can see, the equations start getting a bit longer. We start doing more exercises, which is why I decided to, instead of rushing through the entire book, sort of pacing it out, picking out some questions, and we're just casually just walking through them. Trying to find an easy pace, trying to find an easy method to work through them slowly, nice and easy. Step by step. That's what it is. Okay. Moving on to the next question. Now, I do believe that's definitely right, but what do you say we give it a look? Let's find out. So if we do, now that I know I can actually rely on this device, but I just got to be careful to use the brackets though. Yeah, always use brackets. Okay, so x, whoa, what's happening there? X minus 7 squared Okay, so we have x minus 7 squared equals 36. Try to find an answer here. Okay, sounds about right. And we get x is equal to either 1 or 13. Boom. That is definitely correct. Step using factorizing, step using quadratic formula, steps using completing the square. All these different, you can use literally whichever steps you want, but you can always get the right answer. Right, moving on to the next one. As promised, we're going to do another one. Let's do this time, what am I going to pick? Alright, let's do this one, it looks a bit complicated. Let's do 6x squared minus 7x minus 3 equals to 0. So something has to multiply to give me 18 and add to give me, 8 minus 18, and something has to add to give me minus 7. Now if I do minus 9 and plus 2, I'm going to get minus 18 if I multiply it. If I add it, I'm going to get minus 7. So I can also write this as, which would imply 6x squared minus 9x plus 2x minus 3 is equal to 0. Which implies, now if I take out a common factor, it would be 3x, yeah, 2x, which would end up with 2x minus 3. And if I take out a plus 1 as a factor over here, I end up with 2x minus 3 as the common factor, which equals to 0. Okay, which then implies that 3x plus 1 multiplied by the common factor, which is the common factor of 2x minus 3. Okay, which gives you 0. Right, so now in this case, I have to find numbers for x which would turn either of these terms into a 0. So if I look at the implication, I would say that x would have to be either minus 1 over 3, and that's 1 over 3 because it's multiplied by 3, so it would have to be divided by 3 to give you a 1, and a minus to subject into that. Yeah. So you end with minus 1 over 3, or a minus 3 over 2. Yeah, sounds about right. Okay, and that is the solution for x. I'm not going to check it because I'm fairly certain I've carried out the right steps. I've been doing the right formulas and everything. So yeah, most likely it is right. But if you want to double check, you want to find out, you can do that as well. You do another one, possibly. We'll see how this turns out. Okay, let's do 4x squared plus 17x is equal to, well, plus 17x is equal to 6x minus 2x squared. So we have 6x squared plus 11x is equal to 0. Take out the x. It's a fairly simple one, this one actually. So you get x, yeah, 6x plus 11 equals to 0. Not doing this right. That turns into positive. You get 6x squared, yeah. 17 minus 6 is 11, yeah. And which would then imply x can either be equal to 0, first of all, or it could be minus. Wait, did I put a minus at the top? I did. Yeah, no. Ooh, that was not supposed to be minus. See what I'm saying? That was not supposed to be minus. Very close. God damn. Should have checked it. Got a little bit overconfident. Never get overconfident. And the reason that's plus is because that's minus. So you have to add to get a 0. So if I was to do 3 divided by 2, 2 gets cancelled out. 3 minus 3 gives you 0. Here, it will be 3 divided by 3, and then minus 1 plus 1 gives you 0. So either way, these two are the right answer. There was not supposed to be a minus over there. My apologies. My apologies. Okay, so this one is supposed to be minus 11 divided by 6. Cool. Hey, solving quadratic equations. Isn't that fun? Get to some more intense math. very, very soon. And yeah, just gonna see how it ends up from there onwards. Because now we're going to try a different method. We're going to try completing the square to get the equation, to get the answers, instead of just simply sort of working out, which is like, you know, the normal factorizing method. Obviously, completing the square was a previous option as well. We could have done that, but I chose not to. Let's try doing it now. So we have x squared plus 4x. X squared plus 4x, right. So that would give me I think it would be that, x plus 2 squared, and then I'll get a minus 4. Why? Because let's pretend I had a minus 4, plus 4 over here. Yeah, so that would make a perfect square. So that would be equal to x plus 2 whole squared. Yeah, sounds about right. Here's the fun fact though, like I could literally write something that's proper random. So okay, something that adds to give me let's do this first. So of course I'm just gonna leave that over there. What if there was an alternate, and if I was to sort of complete the square, no, not the square, but like write it in terms of two different equations? I could possibly do that, but that's just too much effort. Yeah, it's definitely just too much effort. You know, I'm just going to leave it as it is. It wouldn't imply anything. It would be equal to that, if anything. Also, just to confirm. Because that would be equal to that, yeah. Okay, yeah, I'm just going to erase all of this out, because that makes it just a little bit confusing. Right, let's do another one. That's definitely the answer, completing the square. Yeah, let's do another one, 7. Completing the square is a little bit confusing theory, to be entirely honest, if you ask me. Well, let's do another one. X squared minus 16x. Right, so we're trying to find out numbers that would add to give you minus 16. And we're looking for minus numbers, of course. So it would be, it would probably be 16 plus 16, so it would be like, half of 16 is 8, possibly, yeah, so 8 times 8 is 64. So if I was to imaginarily, if I had an imaginary 84, well, 64 over here, and that would equal potentially x minus 8 squared, because you would get x squared first, then you get minus 8x minus 8x, and then plus 64, right? So the answer to the blue question should be equal to x minus 8 squared minus 64. And that's the final answer for that one. Again, if you want, you can erase that one. You don't have to worry about it. Let's do another one. Let's try to condense this down into one single step. x squared plus x, I suppose, x squared plus x, which would be equal to, let's see, has to add to give you 1x. Wow. Intriguing, right? Okay. Has to add to give you 1, so it'd be the half of that. So it'd be 0.5, essentially. And 0.5 squared is minus 0.25. Believe it or not. Yeah. 0.5 times 0.5 is basically the half of a half. Is a quarter. Yeah. So it's 0.25. So it would be x plus 0.5 all squared, 0.5x, 0.5x gives you x squared, and multiplied by 0.5, 0.5 gives you minus 0.25. Boom. Sounds about right. I'm just going to mark that as a final. Yeah, 100%. Now I know these ones seem a little bit confusing, but if you guys run back through it, I'm sure it would make sense. That's what these notes in these videos are for, so you can have a look at them and you can go through them at a later point sometime, and you know that you've got the right answers in front of you. So you know how to sort of match the answers to get it right. Let's do this one, 3x squared minus 24x. Trying to get the difference of the squares, so if there's any common factors, I'm going to try and get it out as much as I can. So in this case, we have we have 3 as the common factor, isn't it? So you have 3 times 8. Yeah, 3 times 8. So if we take out 3, we end up with x squared minus 8x. And now this in itself specifically becomes an isolated equation because we're trying to find the sort of completing the square for this one. And if we have 8, we end up with a minus 4. So minus 4, because remember the expansion for a quadratic or a square term is a squared. It's x squared plus, no, sorry, it's a squared plus 2ab plus, or, yeah, plus or minus 2ab plus b squared. So that's the expansion for a plus b squared, or a minus b squared, whichever it is. So anyways, if we're looking at this, so it would be minus 4x, yeah, and that would end up with, so you get a minus 4, which means it would be minus 16, which is due at the end. So you get a plus 16, which is due. So this is also equal to 3x minus 4 minus 16. And obviously that's the squared. Yeah. So that can also be written as 3x minus 4 squared minus 16 times 3 gives you 32 and 48 minus 48. 16 times 3. Who puts 3 slots of RAM at 16 GB? You got to at least put 4, which will give you 64. I mean, come on. Just kidding, but yeah, that's the answer. You can possibly leave it as that one. If you can't, then just leave it as that one. The one before that. Let's do another one. Completing the square. 2x squared minus 5x. And yeah, so in this case, what are we going to do? In this case, I'd possibly suggest taking out the 2 again, because it's not an easy way to get it done 100%. But yeah, we're just going to have to do that anyways. And I'll possibly recommend leaving it in a fraction term as well, rather than going into decimals as we did previously with the number 8. So this can also be equal to, you have 2. And if you want, you don't even have to take out any common factors. Let's just do it this way. So if we do it this way, it will be a little bit more complicated, yeah, 100%. But it's doable. But at the same time, no, you know what? It's always good to take out the common factor. If possible, you need to have a over here as a square number. Square number required. If it's not a square number, then it's always better to sort of set it out, because it would just cause hassles later on in the equation. So if we take it out, we get 2x squared minus 5 over 2x. Right, so that's what it is. Now we're trying to find the squared term, right? So that would be half of that, which would be 5 divided by 4. Cool, so that would end up with, is it 25 divided by 16? Really? 5 divided by 4, half. So we basically got to square that and we're going to minus that as well. Right, so yeah, that would end up with 2. Then we have x squared. No. We have x minus x minus yeah, x minus x minus 5 over 4, all of that squared, minus 25 divided by 16. Okay, and if you multiply that by 2 and everything, you end up with 2x minus 5 divided by 4 squared minus 25 divided by 4. Nope, that's wrong. 8. Right, so I'll possibly say that that is the answer to that one. If you want to double check, let's double check that one as well. I'm just going to double check that one as well. Why not? 2. Oh, come on, man. I'll do this every time. So you got 2x squared minus 5x. Try to solve for this. Right. I want you guys to bear in mind that we were trying the end goal over here was to complete this square rather than solve the quadratic equation. Although I kind of said solve the quadratic equation, then I said solve the equations. Yeah. Should have probably split it up. Should have definitely split it up. No worries, we can split it up now. Complete the square. The square. The square. God damn it. The square. Okay, so yeah, these all complete the squares. It's all a different page, right? Let's move on to the next question. I don't want to do another one of those. I'm just gonna leave it. Let's go back to solving equations. Solve by completing the square. Now bear in mind for these ones we're not going to get an easy question where you can actually find common factors, but we're going to try to get it anyways. So you get x squared plus 6x plus 1 equals 0. So if we try to find any common factors over here to try to factorize this equation, it's going to be rather difficult because something that multiplies to give you 1 is a number and then sort of adds to give you 6. Yeah, it doesn't work out in your head, does it? No. So the way that you would do that is you would basically try to complete the square. So you basically write this down as x squared plus 6x is equal to 1, and then of course you try to complete the square for this bit, which would then imply that x plus 3, I believe, is 3x. Not x, just 3. X plus 3 squared minus 9 gives you 1. And then that would imply that x plus 3 squared is equal to 10. You do the square root, okay, which would imply x plus 3 is equal to square root of 10. Plus or minus, of course. And yeah, finally you just sort of negate it, which would then imply x is equal to plus or minus square root of 10 minus 3. And now of course this basically defines both the values of x, because you have a plus or a minus for the square root of 10. Obviously minus 3. Yeah, the minus 3 doesn't change because it was just a standard thing. Okay, so that's definitely the answer, and yeah, we're pretty confident with that. If you want to try and double check that, let's try to do that. Let's try to erase, delete all. Yeah, so we have I don't understand what's going on. Turns out it's probably broken. That one doesn't really work as well. Okay, we're just not going to use that one. Yeah, essentially, we're unfortunately not going to be using that one. Why is it stuck like that? Alright, let's try writing this down. So we have x squared plus 6x plus 1. X squared. Come on, man. Right, it's important to write the equals 0 because then it becomes an equation. You're not just trying to sort of simplify or by completing the square. Let's find that out. So that'll basically end up with... Now the reason it's 2 root 2 is because we were supposed to simplify the square root of 10. I don't think you can actually simplify the square root of 10 though. Could you? 8 minus 1. Oh my god. Wow. Definitely got that one wrong. It's supposed to be minus 1 over there. There you go, that makes sense. And then instead of 10, Oh, good lord. Right, so that's definitely the wrong answer. Let's just scrap that, take it back to where we lost it. Actually, you know what? Let's just leave it as it is, because technically this was all right. Until... Sorry, if this would have been right, if this was a negative. But since that's not a negative, it's a positive. Gotta do the whole thing again. I'm just gonna do the whole thing again. You know what? Time to erase. Do the whole thing again. No. Oh, wow. Alright, so that turns into a negative, which would then imply x squared plus 6x. Alright, no, we're completing the square for that one, isn't it? So x plus 3 whole squared minus 9 equals minus 1. Which would then imply x whole squared plus 3... Sorry, whole squared... x plus 3 whole squared equals 8 as promised. And then we take a square root of both sides. Of course, like I said, x plus 3 is equal to the square root of 4. Whoa, square root of 8. Square root of 8 is equal to the square root of, so it's 2 root 2 multiplied by square root of 2, as they said, because yeah, that's what it is. Which then implies that would be equal to, and of course you get a plus or minus over there, so you get plus or minus 2 root 2. Okay, and then you end up with, which implies x would equal to be either plus or minus 2 square root of 2 minus 3. And I believe that's exactly what they said it was. Plus or minus 2 square root of 2. 2 square root of 2 minus 3, yeah, sorry. Yeah, good lord. See, so you got to keep an eye out for the operations and the signs. If you get even one thing wrong, the whole equation turns wrong. You get a completely different answer as to what is the right answer. It may look similar, but it's not the right answer. It could have drastic effects. So always double check, and it's always good to collaborate as well. Have people around you who can sort of spot out and problems within the equation. I mean, I of course have a digital thing, but it's better to have people that are with you and sort of solving it. Remember, we used to have a lot of fun working in the classroom trying to find out what the right answer was. Pretty much most days, yeah, when I was in high school. A-level stuff, sorry, in sixth form. So, we have another one. We get, alright, we're going to do this from this, do it a different way. So we get 10 equals 3x minus x squared. I know you guys are confused, like, you can't take a square root of minus x, so don't worry about it. Switch it around. So that would imply that x squared minus 3x is equal to minus 10. Simply just multiply the whole thing by minus 1, and you get the same thing. Yeah. Okay. So basically what I did was I multiplied the whole thing by minus 1, and then that gave me sort of minus 10 is equal to minus 3x plus x squared. And then if you write the same thing either side of the equal sign, it doesn't matter as long as you write the exact same thing. Don't change any plus or minus signs. So that would basically just give you that. Okay. And then, yeah, we take the difference of squares, and we say x minus 1.5, so 1.5. Has to be 1.5, isn't it? I'm just going to do it in fractions because it's much easier. So that'd be 3 over 2 x, not x, sorry, which would be 3 over 2 whole squared minus 9 divided by 4 equals to minus 10. Take it to the other side, which would imply x minus 3 over 2 is equal to, remember the square at first, is equal to, oh, that's a minus 10, isn't it? Wait, why is that a, no, that is a minus 10. Okay, so we get 9 over 4 minus 10, which is equal to 9 minus 40, which is 31 divided by 4, which is a minus 31 divided by 4, which equals minus 31 divided by 4, which equals to 3 and 4, and I believe the number is 7. 7 times 4 is 28. Yeah. And you add another 3, it would be 31. So yeah, that's right. It's minus 31. Oh, it's a minus. Oh, that can be good. I believe that the x should imply, let's just write it out, because it will basically be the right answer, but it's just out of scope 100%. I'm not sure if I took down the right question. Alright, which equals to x minus 3 over 2 is equal to square root of minus 7/3 over 4. Do not try to write that in your calculator, you probably get an error. Should then imply x is, of course, that'd be plus or minus. X is equal to 3 over 2 plus or minus the square root of a negative number. And there are ways to find this out. You're not going to learn this just yet. This is further maths. I don't understand why did I pick this question. But yeah, that would basically be one of the answers. Let's try to figure this one out on the professional calculator. See what it has to say. 10. Oh my god, this actually doesn't work. Why? Ten is equal to 3x minus x squared. Yeah, see? I had to tell you, it was something a little bit complicated, essentially. You swap sides, and yeah, they tell you to kind of do that, blah blah blah. That's a little bit complicated. I don't understand why they have to do that. Cool, yeah, so yeah, do that, blah 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 blah. And you end up with minus 31 over 4. Yeah, That's absolutely it. That's exactly what we ended up with. Now you see the I over there, that's basically like a square root of a negative number. This doesn't really apparently exist, because no matter what you square, even if it is a negative number, apparently you always end up with a positive. Because if you do minus 3 multiplied by minus 3, you end up with a positive number. And it's weird if you try to think about it, because if you do minus 3 multiplied by minus 3, so it's basically minus 3 multiplied by sort of minus 3. Yeah. Always get a positive number. It's weird. So, anyways, we're going to move on. Yeah, this was definitely right. You did it right. The reason I was like, yeah, no, I messed up again. I was doing the wrong answers. Don't know what's wrong with me. You know, I know I should have just called in sick, to be entirely honest, but, like, it's good to be carrying on work. And look at how much work we've done. Do you see that? We've done a lot of work, you know. It's 21 whole pages. It's good. Getting work done. Alright, let's try doing another one. Take this one nice and slow, because after what happened last time, I don't want to get something random adding up into the equation. Always finish up at the end, regardless of what conventional mathematics tells you. You know how there was this question where it was like, you know, complete the square for this equation. I believe it was for this one. Yeah. If I was to solve it, I could have just, you know, taken x as a common factor, but I didn't even think about it because we were doing completing the square. So you need to think outside the box. You need to be like, okay, you know what? Doesn't matter what they're asking me to do. What are they not asking me to do? Maybe the answer lies somewhere within there. Yeah, so that equals 0. I'm just going to multiply everything by minus 1. Or divided by minus 1, doesn't really matter, because you still end up with 0. Yeah, so we would get, which would imply 2x squared plus 6x minus 15 is equal to 0. Should then imply 2x squared plus 6x is equal to 15. And then that implies, you know what, let's try to make it even thinner. Which implies x squared. Oh, that's way too thin. X squared plus 3x is equal to 15 divided by 2, which would then imply x plus 3 over 2 whole squared minus 9 over 4 is equal to 15 over 2, or 30 over 4. Which then implies x plus 3 over 2 whole squared is equal to 39 divided by 4. Because, you know, went to the other side, added it up. Which then implies x plus 3 over 2 is equal to the square root, well, plus or minus the square root of 39 divided by 4. And 39 divided by 4 is actually 9 and 3 divided by 4. Right, so, which would then imply x is equal to minus 3 divided by 2 plus or minus square root of 39 divided by 4. And if you want to simplify that further, because you get 9, 3 divided by 4, you can also write this as minus 3 divided by 2 plus or minus 3 square root of 3 divided by 4. And if you want, technically the 4 can even come out, so you would end up with am I doing this right? I feel like I'm not doing this right. Yeah, because this is 9 plus. Ah, I see. You cannot write it as that. No, you cannot write it as that. Because this is 9 plus 3 over 4. Yeah, it's 9 plus 3 over 4. It's not 9 multiplied by 3 over 4. So you see, keeping an eye out for your, your operators is very important, because as you just saw right now, I was going to do something that's completely doesn't make sense. But yeah, if this was on its own, if this was just 9 on its own, it could have been done. But because it's 9 plus 3 over 4, I don't think it can be done. Let's try confirming this in the cloud. See how this works. This application is actually powered by Maths, Microsoft Maths, so thank you to them. 15 minus 6x minus 2x squared is equal to 0. Again, all hexagon on me, bro. Completing the square, and they end up with, what do they end up with? Yeah, they end up with 39 divided by 2. So root 39 divided by 2. I think the easiest way to do that, technically speaking, yeah, we could actually take out the, if we do that as a common, we could actually take out the 4. So yeah, we could probably do that. So if you write that as, if we leave it as 39 divided by 4, and yeah, we do that, so then that would be x is equal to minus 3 divided by 2, and then you have plus or minus root 39 divided by 2. And regardless of what that is, you basically just affect the top, because plus or minus, because the denominator is the same, so you can even write that as minus 3 plus or minus root 39 divided by 2. And I believe that's what they had. It takes a while and it's a lot of effort, but once you get there, you can actually relate to what exactly the requirements are. Thing is, most of these equations that you're going to be doing, it's just a path without a defined end. So wherever you feel like you can stop, ideally that's a good point. But of course you need to keep in mind that they want you to simplify the equations wherever you end up, and of course you need to have like a rationalized denominator is essentially what they're asking for. So unless you feel like keeping something as an irrational is going to help you in the next stage of the question, possibly say just keep it rationalized. I'm going to solve some more equations, and yeah, we're going to solve some more equations. Okay, so now traditionally in the textbook it's asking me to actually solve these using a quadratic equation, but we're not going to do that. We're just going to do completing the square, because that's literally just the easiest bit. And completing the square is actually how the quadratic formula is derived. So if you know how to complete the square, you can literally solve pretty much every quadratic equation that you come across without fail. So if that equals to 0, which would then imply x squared plus 3x is equal to minus 1. I've got to get the operators right this time. Which then implies x plus 3 over 2x whole squared is equal to minus 1. Great. Why is it always ending up with stuff like this? Like, seriously, wow. Giving the solutions in third form. Okay, well, I can do that, right? Yeah, sure I can. Right, I also have to complete the square. My apologies. See, that's where I go wrong. You go minus 9 divided by 4 equals minus 1. I'm actually feeling much more happy now. Okay, cool. X plus 3 over 2. And there shouldn't be an x over there, is there? No. It's just squared. Squared is equal to, what is this? 2, 1 over 4 minus 1 gives you 1 over 4, which is actually 5 over 4, and which would then imply x plus 3 over 2 is equal to this plus or minus the square root of 5 over 4, which is also equal to plus or minus square root of 5 divided by 2, which then implies x is equal to minus 3 plus or minus square root of 5 divided by 2. Remember, 2 is the common denominator when you move it over. So if I write it in the bigger form, you get minus 3 divided by 2 plus or minus square root of 5 divided by 2, and that would just equal, it would equal, not imply, it would equal minus 3 plus or minus square root of 5 divided by 2. Okay, let's do 7x squared plus 9x plus 1. Now, based on the let's do this one based on the quadratic formula. Now, the quadratic formula actually states that x is equal to minus b plus or minus square root of b squared minus 4ac. And you divide that by 2a. Do you believe that's the equation? Yeah, 100% is the equation. Okay, so we're going to try doing it this way, and we're going to see what we end up with. So in this case, we have a, b, c, and of course x is whatever it is. And of course, like, if you look at the definition for the quadratic equation, you can actually sort of derive this. We're going to derive it in the next step. But let's try working out what it is first. So, right, so x can be equal to, we did the plus and minus bit, right? Yeah. Should have said that's the answer. It's also the answer, right? So we got the answers on the line. That's good. Okay, so x is equal to minus 9 plus or minus 2a, which is 14. And you have the square root of b squared, which is 81, minus 4 multiplied by 7, which is 28, multiplied by 1. So which is equal to minus 9 plus or minus square root 81 minus 28. 81 minus 28, 61 minus 8. 61 minus 8 gives you 53. 53 is, and I'm pretty sure I say this, it is a prime number, if I'm not wrong. 14. If I just try to find out, let's try doing that. Square root. You won't tell me like that, would it? No, because it's not a scientific calculator. But if I just do it on my calculator, do I have a calculator here? Pretty sure I had a calculator here somewhere. Yeah, let's try doing it this way. Square root of 53. Yeah, apparently there is no specific square. Is 53 a prime number? I don't know. How am I supposed to find out? Probably is a prime number if you ask me. I think it is a prime number. Let me just try to find that out. Is 53 a prime number? If it isn't, then yeah, I mean, you can just pretty much leave it as that. And yeah, that would be the right answer. So yeah, that'd be it. And I should double check this equation if we were to solve this using complete the square. So if we were to solve this using complete the square, it would end up like so. So we'd have 7x squared plus 9x equals to minus 1, which would then imply yeah, it's not easy to actually solve this with complete the square, but we're going to try anyways. See how it works. If you divide the whole thing by 7, I think it will make it easier. So we get x squared plus 9 divided by 7 x equals to minus 1 over 7. Okay, and then we do, which implies x plus 9 over 14 whole squared is equal to, oh right, so you got to add the minus as well. 9 times 9 is 81. 14 times 14 is 14 times 14. No, I'm thinking 12 times 12. 14 times 14 is 16. 4 times 1 is 4. 4 times 1 is 4. That's basically 140 added 28, 28. So that's 40, 56. So 140 plus 56. 196, I presume. 196 is equal to minus 1 over 7. Wow. Yeah, this is turning out to be a chore. Which implies, which implies x plus 9 over 14 squared is equal to 81 divided by 196 minus 1 over 7. Interesting, right? Yeah. So if you do 196 multiplied by 7, what's the lowest common multiple? Is 196 divisible by 7 in terms of whole numbers? I'd probably say that no, it isn't. Maybe it isn't. Let's have a look. 7 times, so yeah, we try to divide that by that, so we get 114 left over with 14, 5, 56. 56. 49 plus 7. 56, yeah, 196. So that's is that 7 multiplied by 56? Wow, it's pretty heavy, isn't it? Oh my god. 7 multiplied by 56. Am I right? Did you get 7? No, that's wrong, no. It'll be 7 multiplied by 2, 5, 6, 7, 8, 28. Yeah. 7 multiplied by 28 is 196. Yeah. 7 multiplied by 28. Fourteen multiplied by 14 is 196. 7 multiplied by 28 is 196. Is it? Yeah, I've got that right. So it would be 7 multiplied by 28. Yeah, so you get 28 at the top as well. So which would imply, right, we did the implying again. X plus 9 over 14 is equal to the square root of 81 minus 28 divided by 196. We all know what that means. Which would imply x is equal to 81 minus 28. Good, let's do this. 61 minus 8. 61 minus 8. 61 minus 8 is 56. 53. Right. So square root of 53. So you see we're ending up in the same place. We get minus 9 divided by 14. And we end up with square root of 53 at the top, plus or minus, of course. Divided by 14. And that will give you, which implies x is equal to, sorry, apologies for that. X is equal to minus 9 plus or minus square root of 53 divided by 14. And that is another way to get to the same place. It's a lot of working out, and there's a lot of like equations and stuff going on, a lot of additions, subtractions. So it is always a bit more handy if you know the equation, if you know the quadratic equation. So yes, of course, you can get the exact same answer. And yes, we did get the exact same answer. But it is definitely much more easier, as you just saw, to work with the quadratic equation. While yes, of course, keeping in mind completing the square, you're actually learning how to sort of, you're sticking with the roots of how to exactly solve quadratic equations, which is favorable for me, because you know I appreciate when people know the core principles of whatever it is that they're working on, so that they know where it is derived from. Speaking of deriving, let's do a derivation for the actual quadratic formula, and we're going to use multiple variables over here. So don't be just try to keep up, and don't be intimidated by it. Yeah, just keep an open mind is what I'm asking. Okay, so in this case, what we're going to do is, all right, so let's just label this as bonus. Whoa. Right. Whoa. Right, last time. Whoa. All right. So we have ax squared plus b. Is that a b or a d? No, that's a b. Bx plus c is equal to 0, where a, b, and c are constants. A, B, and C are constants. Well, technically they could be variables as well, but we want them to be constants. And technically they are variables, yeah, essentially. Well, they're variable constants, because at some point for specific equations they're going to be constant, but to derive the quadratic equation they're variables, which is just so weird. And x is the constant for us. Anyways, let's do this. So the way this will proceed is we're gonna basically do the exact same steps for completing the square. So we do ax squared plus bx is equal to minus c, and then we say we're gonna divide it by a, of course. So we end up with x squared plus bx. Don't forget the implies, because that's every time that it implies, divided by a is equal to minus c divided by a, because you're dividing every single term that's separated by an addition or subtraction by a. And we can say which implies x plus b divided by 2a is equal to, whole squared minus b squared divided by 4a squared. It's probably just equal to, it doesn't have to imply anything, yeah, because it would be equal to the exact same thing. Yeah, so then that implies x plus b divided by 2a whole squared is equal to, let's see what's on the other side. We have b squared divided by 4a squared minus c divided by a, which would then be equal to b squared minus 4a, because that's the lowest common multiple. 4a squared is the lowest common multiple, and you divide 4a squared by a to give you 4a at the top, 4ac at the top actually, and divided by 4a squared. And that would imply x plus b divided by 2a is equal to the square root of b squared minus 4ac divided by 4a squared, and that equals square root of b squared minus 4ac whole divided by 2a, square root of the constant, square root of the variable. So that implies x is equal to minus b divided by 2a plus or minus, right, forget the plus or minus, keep forgetting the plus or minus, don't ever forget the plus or minus, especially like 2 steps into the equation. That's pretty sloppy even of me. Plus or minus square root of b squared minus 4ac divided by 2a. And we all know what that means, which implies x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. And that is a quadratic equation. So as you can see, you can actually use the basics of math to try and derive yourself the equations. There's a lot that goes into sort of deriving equations, and frankly speaking, it is quite the tedious task. But once you have a derivation, it allows you to use basic operators and basic operators to understand what it, to basically create a relation and to equate specific terms. in equations. It's a lot of work, and it's very essential that you make sure that you're not making mistakes such as the plus or minus. But at the end, you can succeed. Yeah, 100%. Okay, so yeah, let's get through. So that was the bonus panel. This is just sort of deriving the quadratic equation. You know, let's just reselect all of this, move it down. I'm just going to label this deriving. Deriving the quadratic equation. Perfect. So that was that. That's actually a lot of work, frankly, to be speaking, and hopefully you guys have been keeping up as well. But I believe there's another half an hour left, and I really don't want to try taking many breaks, because, frankly speaking, there's a lot of work that there is to cover. So yeah, that's the only thing. But we've actually covered quite a lot. So we've covered quadratic equations. We've covered we've covered sort of basics of algebra, learning how to simplify, learning how to expand. We've covered basics of surds and indices. We went on to quadratics. We even solved some quadratic equations, different ways of solving quadratic equations. And yeah, I think it's been quite productive so far. What I am going to do is we're going to do a bit of equalities and inequalities. So we're basically going to move on to doing some simultaneous equations, which I know people have been doing before, and we're going to carry on with simultaneous equations and equalities and inequalities next time as well. So yeah, we'll do that. But for now, we're going to take a 5-minute break, and I'm going to meet you guys back in another 5 minutes, and we're going to start off with doing simultaneous equations. Okay, I'm going to see you guys back at 20:35, based on the clock that's on the screen. Okay, so hello everyone, we're back, and we're going to be doing some simultaneous equations. You know, the purpose of having these 5 minute breaks every single time is just so that you can take some time to take a breather, because, you know, carrying on doing so many questions all over and over again, it takes a while, and it can sort of affect the way that you think and your concentration as well. So I always recommend take some break, drink some juices or something. Having a smoothie is always beneficial, you know. Yeah, because smoothie can pack quite heavy punch in a small package. So yeah, always keep yourself refreshed and keep it real. Okay, let's start off by doing a simplistic simultaneous equation. This is pretty much a linear equation, if you guys know what that means. So we have 2x. Right, we're not going to do it with this. We're not going to do it with that thick. You know, you can actually edit all the colors. That's pretty nice. Yeah, no, we're not going to do it with this thick of a pen. We're going to sort of lower down that thing. Right. Start off with the first question. I'm going to start off with a linear equation, of course. 2x minus y is equal to 6. 4x plus 3y is equal to 22. And both of these live in the same realm. What that means is that this y is the same as that y, and this x is the same as that x. Okay? It's kind of implied. So which would imply, let's see what we can do. Let's multiply this entire equation by 2. Okay, so this would also would imply 4x minus y, minus 2y, because you're multiplying everything by 2, is equal to 12. Done that right? Yes, I have. Okay, now there's two ways for you to do that. What we can do is we can basically say that in this case 4x is equal to 22 minus 3y, and in that case we can also say that if 4x minus 2y is equal to 12, it would imply that 4x is equal to 12 plus 3y. And what we can do is we can either substitute. So we're just going to sort of substitute. And what that basically means is that both of these have become equal to each other now, because both are 4x. So which would imply that 22 minus 3y is equal to 12 plus 3y. Is it 3? It's not 3y, is it? It's 2y. Gotta be careful. 2y. Plus 2y, which implies, if we take the 3 onto that side, 12 onto that side, we get 22 minus 12 is equal to 3y plus 2y. So that would imply that y is equal to 10 divided by 2. And if you want to take it the long way, you basically say 5y is equal to 10. Oh, it wasn't 10 divided by 2, which then implies y is equal to 10 divided by 5, which gives you 2. Okay, now we can substitute the value for y into any one of these equations, whichever you find easier. I possibly would say you substitute it into the original one. So we have 2x minus 2 is equal to 6. Which imply 2x is equal to 8, which imply x is equal to 8 divided by 2, which is equal to 4. So we have the answer for x, and we have the answer for y. Okay, cool. And if you want, you can actually write them down separately. So you can say which implies x is equal to 4 and y is equal to 2. And that is final. Let's do another question. 3x plus 8y is equal to 33. And 6x is equal to 3 plus 5y. And now this would imply that 8y, what's the easiest way to do this? I'm probably thinking to multiply this, the top one by 2. So we end up with 6x plus 16y is equal to 66. Sounds about right. Yeah. Now we already have the first equation, which equates in terms of 6x. And now we just have to find the second equation. So if 6x plus 16y equals 66, it should imply that 6x is equal to 66 minus 16y. Substitute them both, because 6x is equal to that, that means that is equal to this. Okay. So, if we put that in, we get 3 plus 5y is equal to 66 minus 16y. And that would imply 16y plus 5y is equal to 66 minus 3. So you would end up with essentially 63 is divisible by 9. 63 is divisible by 9. So then you get 72, you get 81, and you get 90, yes. 63 is divisible by 9. 9. Not 21. No, actually, possibly 21 as well. So 16 plus 5y is 16y plus 5y is 21y. Yep, 16y plus 5y is 21y is equal to 63, which implies y is equal to 3. If you want to take the long way, 63 divided by 21, and that's definitely 3. Substitute that into either the first or the second equation. I'm possibly thinking just substitute it into the 6x equals 3 plus 5y, which would then give you, so yeah, it would basically, if you take that one down, it will give us 6x is equal to 6x is equal to 3 plus 15. It's 5 times 3. Which ends up to be 18, which would imply x is equal to 18 divided by 6, which is also 3. Isn't that interesting? That's very interesting. Yeah, and then what we just do is just write x is equal to 3, and so is y. You just write equals to y. Sorry, my apologies. I'm not sure what just happened there. It seems to have been some kind of breakdown in terms of the live stream. I don't know, there's, at some point possibly this might happen again, but we're just going to try to sort of stay on point and stay focused if it doesn't work out. Yeah. Okay, moving on. We're going to do another simultaneous equation, of course. We're going to try finishing another 3 simultaneous equations because, you know, we'll try to get them done. And we're going to try and see if we can actually get a quadratic equation within those simultaneous equations. So hopefully things are going to get interesting. So yeah, let's stay tuned. Cool. Yeah, and then hopefully the next time, in the next session, we're just going to go through some inequalities and equalities, and how to solve equations based on that, how to work with them specifically. But yeah, things get pretty tricky when you try to start multiplying and everything with those. So yeah, okay, let's do some more equations, and then we'll move on to a different, we'll just say, we'll pack up for today, and then we'll move on to the next questions for the after. So I'm going to try a different method now, which is by elimination. I'm sure most of you would have tried this when you were in your previous years as well. Everyone's probably tried this at some point. They've been given this equations to do. But anyways, let's try that now. So we have 3x, and we'll try doing elimination. Previously it was substitution. Remember, whatever the question's asking you, it doesn't really matter as long as you get the right answer, in my opinion. But of course, you want to bear in mind whatever the question has asked you to do, and who has asked you to do the question. You need to question yourself. -2. Okay, which would imply, let's just multiply that one by 3, because I don't see any other specific multiples. So we get 9x minus 3y is equal to 7. Yeah. And now what we're going to do is we're just going to add both of these equations. Okay. Well, not those equations, like these equations. So 10x plus 3y equals -2. We're just going to add these both equations. So that's elimination, essentially. We're trying to eliminate those. Cool. So we end up with 19x is equal to 5, which implies x is equal to 5 divided by 19. Am I getting this right? I feel like doing something wrong. No, sounds very much right. Yeah, I do apologize if you guys hear any dogs barking in the background. My neighbor has a terrible habit. It's going to cost him someday. But anyways, probably for some other time. Right, so we substitute that. Of course, we have to substitute the value of x into a y equation. And yeah, we'll get our answer that way. So if we say 3 multiplied by 5 divided by 19 minus 7 is equal to y. Right, I'm just going to write that up properly. Minus y is equal to 7. Same equation. So we're just using that one. Which would then imply sort of 15 divided by 19 minus 7 is equal to y. Which then implies y is equal to 19 multiplied by 7. Good lord. 19 times 7. It's pretty heavy, isn't it? Yeah, all I know is just going to be 6. We have 19 at the bottom. And 15 minus 9. So right, it'll be minus 6. 19 at the bottom. And 7 at the top. No. It'll be 19 minus 5, so it'll be 4 at the top. Yeah. Yeah. So y is equal to that, and x is equal to 5 divided by 19. That's final. And that was elimination, because, you know, we sort of added both the equations. I'm not sure how that actually works in realistic terms, but yeah, we basically sort of... It's essentially substitution, but an easier way. It's supposed to be an easier way. Anyways. Alright, let's do another one. These terms are definitely coming out a little bit wonky, isn't it? Alright, let's do another one. Let me just quickly try to calculate it, because y would be equal to... Yeah, no, I can't calculate that in my head. No, not a chance. Yeah, we're just going to do one more of this, and we're going to try to attempt a quadratic equation before we say goodbye for today. 3x... No, I've already done that one. Alright, let's do x plus 3y equals 11. And let's also take into consideration 4x minus 7y equals to 6. Multiply the top one by 4. Not sure what's going on here, and slightly concerned. Yeah, once again, I'm not entirely sure what's going on, but apparently there's a poor stream health. Don't know why is that. It's weird, but if you guys have any sort of concerns, just just bear with me. Okay, I'm going to try to do this one quickly now. Alright, so we're going to multiply this by 4, which should basically imply that 4x plus 12y is equal to 44. What we can then do is imply that 4x minus 7y is equal to 6. And if we just do minus both of them, right, so that's a positive sort of, we're trying to add them, we're trying to minus these ones. So it should then imply that 4x just gets cancelled out. And 12 minus 7 gives you 19y again, which then equals 44 minus 6, which gives you 38. 19 times 2 is 38, which implies y is equal to 38 divided by 2, which gives you 2. Oh no, divided by 19, my apologies, which gives you 2. Okay, now once y is equal to 2, we're just going to substitute it into this equation because it's much simpler to do that. X plus 3 times 2 is 6 is equal to 11, which implies x is equal to 11 minus 6, which implies x is equal to 5. Okay, so if x is equal to 5, y is equal to 2. That's final. Alright, now we're just gonna do one more equation. We're gonna try and push in a quadratic equation into this, because the next time that we're back, I want to try and get a I want to try and get have done some sort of further, more expensive equations, such as algebraic divisions, fractions, and we also have to do partial fractions. So we're going to spread that out over the next 2 sessions. We're going to start off with some more inequalities. We're going to start off with inequalities. We're going to do algebraic divisions. and work with some fractions, and then finally do partial fractions right at the end. Okay, so let's do another one. And now this one's going to be an actual question form, so this just prepares you for what's to come next. Okay, so we're going to try to do it in that format. Okay, so this is that the fifth question? Yes, it is. Okay, 5. I'm going to write out the question in red. So it says, find the coordinates of points at which line with equation y is equal to 3x minus 1 intersects the curve with equation y squared minus xy is equal to 15. Interesting. Okay, now, so essentially what you got to do is you just basically have to write them as simultaneous equations. So you have y is equal to 3x minus 1, and you have y squared minus xy is equal to 15. And if y is equal to 3x minus 1, we can essentially substitute it, because it's very easy to substitute, which would then imply sort of 3x minus 1 whole squared minus minus x 3x minus 1 is equal to 15. Okay, and now that would imply 9x squared minus 3 times 2, so it'd be 3x, so it'd be minus 3x, and then plus 1. So that would be, I think I should do it on a new line. Okay, so this would imply 9x squared plus 6x, minus 6x plus 1. That's that one expanded, and we end up with minus 3x squared minus x is equal to 15. And we need to imply, so that would basically imply, take the 15 over that side as well, all in one step. So we do 9x squared minus 3x squared leaves you with 6x squared. You get minus 6x minus x leaves you with minus 7x. And you get plus 1 minus 15 leaves you with minus 14. Yeah. And that equals 0. Okay, now when that equals 0, what we can do is just basically solve for this quadratic equation and see what it turns out to be. Okay, very simple, very much easy, just like that. Just need to confirm, reassure myself that I've done the right equation. Conversions. Oh, see, that's where I went wrong. That is supposed to be a plus x. Because you get minus x multiplied by 3x, gives you minus 3x squared. And you get a minus x multiplied by minus 1, which will give you a plus x, not a minus x. So effectively, this is not minus 7x. This is going to be 6 squared, which is because 9x squared minus 3x squared. And this would be plus, no, sorry, it was to be minus. So you minus 5x rather than 6x. There we go. That actually makes it so much more simpler. I was like, I don't know if I would complete the square, because that does look a little bit dodgy for me. Anyways, yeah, so that's what it is. 15 minus, so minus 15 plus 1 gives you minus 14, 100%. Definitely makes it much easier. We can find common factors now. Yeah, we can definitely find common factors now. Okay, so 6 times 4 is 24. 6 times 1 is 6. 6 plus 2 is 8. 84. Something that multiplies to give me 84 and adds to give me minus 5. So I'm probably putting my bet on 12. 12 multiplied by, so minus 12 multiplied by 8. It will be 8, 84. Yeah, 8 times 2, no. 8 times 2, 7. Minus 12 multiplied by 7. 7 times 2 is 14. 7 times 1 is 7 times 4. No, 7 times 2 is 14. 7 times 1 is 7 plus 1, 14. Yeah. So it'll be, and 12 minus 7 gives you minus 5. So, just 5 actually, yeah. So it'll be minus 12 and 7. Those would be the common factors for that. So which would then imply 6x squared minus 12x plus 7x minus 14 equals to 0, which would imply, so we take out the common factors, we end up with 6x minus 6x, and then you have x minus 2 as the common, plus 7, and then you have x minus 2 as the common, gives you 0, which would then imply that 6x plus 7 and then has a common factor of x minus 2, which then equals 0, which then implies x can either be 2 or it can be 7 divided by 6. So either of those, it'd be minus 7 divided by 6. Yeah, I'm just going to write that properly. Minus 7 divided by 6. So if I substitute it back into, so we found the values of x, substitute that back into y, we end up with y is equal to 3 times 7 divided by 6, and that turns a minus. And that becomes 2, 7 divided by 2, minus 1. So it'd be minus 7 divided by 2 minus 1, which equals, so if I take that into sort of normal thing, it'd be 3.5. So it'll be minus 4, 1 over 2. Yep, absolutely. Minus 4.5. If x is equal to minus 7 over 6, which is basically sort of 1 and 1/6. So if it's minus 1 and 1/6, it's minus 4.5. If x is equal to 2, yeah, if x is equal to 2, then y is equal to 3 times 2, 6, minus 1, which is equal to 5. If x is equal to 2. So there's your answers. I'm just gonna do that. Right, those are your answers, 100%. And if you want, we can try and double check them. Yeah, let's try and double check them, see if you got the right answers. So we had y. I was doing that thing again. So we had it where it was, yeah, still broadcasting, that's fine. So we had y is equal to 3x minus 1, and we had y squared minus xy is equal to 15. Simultaneous equations, let's give that a go. See what it comes up with. Okay, cool. Yeah, so like we said, if x is 2, we get y is equal to 5. And if x is minus 7 over 6, we get y is equal to minus 9 over 6. 100%? That does seem like that it made sense. Okay, so if you have been following through and you have been able to actually keep up with the pace, then that's really good. If not, please drop me a comment later on if you are ever rewatching this. And if, you know, for whatever reason I'm unable to read it by the next session, I'll try to read it by the session following that and make some changes into hopefully the third session from now on. But anyways, so far we've had quite some progress. We've covered quite many topics in a very short period of time. And if you notice, like, the first session was literally just jam-packed with basic mathematics, because I don't want you to get wrong the solving of basic equations, equalities, and you know, just working with operators is very important. So what we're going to do next time again for the inequalities and the equalities bit is we're going to try and bulk feed many equations all in, just so that we can work out what it is like to actually work with such equations and expressions. But anyways, for now, I think that's pretty much it. Hope you guys enjoyed the show. I have very much enjoyed doing the math here today, and it does intrigue me that we've come this far within 2 sessions, and I can appreciate that it's a lot of work going behind the scenes. But just to bear in mind that these sessions are not to teach you what to do; they're just sort of to make people understand what it's like to actually do mathematical equations hands-on. So I don't know the answers for these as well. I haven't done these equations before. Even if I did them, it would have been ages ago, like 7-8 years ago, and I definitely don't remember the specific workings for every single one of those equations. And as you can appreciate, I've been getting some of those equations wrong as well. Some of the expressions and the equations where they're asking me to solve. So the point being there is that it just basically helps build confidence as you go through the equations one by one, and it helps you practice, and it helps me practice as well, because even though I'm an engineer and I get some stuff done which requires some serious math skills, regardless of that, it always benefits to go back to the basics, because they are the ones that have brought me this far, and gets me to do all of this stuff. So yeah, doesn't matter what level you're at, practicing can always be good. So keep that in mind and take it nice and easy. Whichever equation or problem they send your way, just take it easy, take a deep breath, run through the steps nice and easy. I think that's the cue. Does it take a photo? Probably does take a photo. I don't know. But I'll try to figure that out next time. How does it take a photo? It's just so weird. Like, what does it do that? I don't know. But yeah, so I'll try to figure that out next time. But anyways, it was great working today. Hope you guys had fun. Hope you guys caught up to the math as well. And hopefully I wasn't going too fast. But anyways, keep me up to date, and peace out until next time. I think what's going to happen is these videos are going to go on for free now. So there's no need for you to have any tickets, which definitely it proves to be beneficial for you guys. So, having said that, I don't know what it is. So, what it is we're going to catch up from here next time, and we're going to do some nice maths moving from here on onwards. Thank you so much, guys. We actually did 3 hours of working out today. Pretty solid. We took less breaks, which means we're actually getting there. Keep up with me, and we're gonna hit the target at some point. Yeah. Peace out, everyone. Hope you guys have a lovely week and the rest of your time. Still trying to figure out what's the easiest way to end